Alright, in this video I'm going to show you how to apply properties of exponents. More specifically, how you can apply properties of exponents to situations that have rational exponents. Now, rational exponents is when we have exponents, but the exponent is a rational number, which is the fancy name for a fraction. So what we're going to find is the basic properties of exponents, which you should know at this point. And I'm going to show you how they still apply even though we have rational exponents. So, other thing that we need to keep in mind is we want to simplify each expression. So we are not done until we think, all right, there is nothing else I can do. So this first one, I have 8 divided by 8 to the 2/3 power. What's happening here is we have an exponent on bottom, but it doesn't look like we have an exponent on top. Even though it doesn't look like it, we actually do. That exponent is 1, 8 to the first power. So now we have both of them with exponents. Now the property of exponent that we're going to apply here is whenever you have the same base and you're dividing them, what you can do is you can take the exponents and subtract them. So this is equivalent to 8 to the first minus 2/3. So you take the exponents and subtract it. 1 minus 2/3. So now what we can do is we can do 1 minus 2/3. So that's the same as 8 to the 1/3 power. Now if you're not very good with doing 1 minus 2/3, you could type in a calculator and do 1 minus 2 divided by 3. And what that's going to do, it's going to give you a decimal there. It's going to give you 0.3333, so on and so forth. What you can do on a calculator is you have that math button. So math, and the first option there is frac. That'll change any decimal to a fraction. So we have 8 to the 1/3 power. So I applied the properties of exponents, but again, we need to simplify each expression. So looking at this, we want to see, can I go any further? So I'm not really sure, so what I'm going to do is I'm going to switch this over to radical form and see if I can do anything with that. So that is the same as the 3rd root of 8. And at this point, we should be able to kind of remember, can we do the 3rd root of 8? So we're asking ourselves, what the 3rd power is 8? If you're not really fresh on it, you could always use your table of powers and ask yourself, all right, the 3rd power, is there anything to the 3rd power that's 8? Well, in this case, it is 2. So to completely simplify that first one, we get all the way down to 2. All right, next one here, we have 2 to the 3rd power times 2 to the 3rd power inside parentheses, and on the outside we have this exponent of 3. What I'm going to do is I'm going to work on the inside and work my way out. So what we have here is we have similar bases with 2 and 2 exponents there, and these are multiplied together. The rule here, so when there's division in the original, we subtract the 2. When there's multiplication there, what we're going to do is we're going to add. So I'm working inside the parentheses here. So when you have the same base, the base is going to stay the same. What we can do is we can take the exponents there, 1/3, and we're going to add it to 1/3. And we still have that exponent of 3 on the outside. So 1/3 plus 1/3 is going to be 2/3. So inside the parentheses there, using properties of exponents, I have 2 to the 2/3 power. Still have that power of 3 on the outside. We haven't completely cleaned up my exponents here. The other rule here is what we're going to do is I have an exponent on the outside and an exponent on the inside. Notice how there's this parentheses separating them. And kind of the rule of thumb I use to keep everything straight is whenever you want to take, the pen's dying. Whenever you want to take an exponent and go through parentheses, what we're going to do is we're going to multiply the 2. So we're going to take 2/3 times 3. So what's going to happen there is you're going to multiply the top. So 2 times 3 is 6. Bottom stays the same. So it has 6 over 3, which you should know 6 divided by 3 is 2. So what I end up there is 2 squared. Now again, we want to make sure we're completely simplified, make sure we can do everything we can. So I have 2 squared here, which is 4. And then my last one, so I have 16 to the 1/2 power on the inside and a -1 on the outside. Remember, if you ever have exponents on the inside and outside of parentheses, you want to get them together, what we're going to do is we're going to multiply. As you go through parentheses, we're going to multiply. So I'm going to take 1/2 times -1. So 1/2 times -1 is just -1/2. So what we end up with is 16 to the -1/2 power. Next property we need to remember is whenever you have a negative on the exponent, what that's going to do is going to help us get the reciprocal here. So we're going to end up with 16 on the bottom, but now we're going to have a positive 1/2 power. A common way some high school students think of that is when you have a negative exponent, what you're going to do is they say flip it. So this was on top, it's now on bottom. So I cleaned up some of my exponents there, but we're not done. We'll make sure we are fully simplified there. So what I'm going to do is look and see if I could do with anything with a 16 to the 1/2 power. So what I'm going to do is I'm going to change that to radical form. When you take this to radical form, we're going to have a 16 inside the radical. And it would be a 2 there, but we don't write it. So what I have is 1 divided by the square root of 16. Well, the square root of 16 is 4, so I end up with 1/4. So that was applying properties of exponents. The big thing is when you have two pieces that are divided, you're going to subtract the exponents. When you have two pieces there that are multiplied together, not through parentheses, you're going to add the exponents. If you have exponents on both sides of parentheses and you want to go through the parentheses, that's when you multiply. And the final rule is with that negative exponent, you need to look out there. That's going to help you make some fractions in. Flip it. Again, that is properties of exponents.